No.
Can you track that?
Yes and no. So they're basically what's happening is certain really active regions, when another gene needs to turn on, the genome will bring that other active region nearby, so those things will be in closer proximity. And the Parker lab has taken this to a whole nother level where we've seen it on a couple of one-on-one instances. They're seeing it where if enough of these happen, it forms a bubble, like Jell-O in the cell. Because there's so much crap and such. Who's the architect? I read somebody who's an architect. Nobody's an architect. Okay, it's kind of like building a house.
He's a builder.
Builder. Okay, so yeah, that RNA is essentially a polymer. It's like 2x4s. But if you put them in the right shape, you can get a room or a roof or different parts of the cell. And so RNA is as like a self-forming house. So like if you threw all the 2x4s out and they just sort of landed in the right spots. And depending on the blueprint, which would be the DNA, or what's being expressed in the cell, you would get different architectural landscapes. That's what Roy's working on. So we want to figure out how these things are coming together to make all of a sudden go, and they make their own little world. The same way all Jell-O is a bunch of proteins heated up, denatured, and they come back in a lattice. That's what the RNA is doing too. And then that can then bring chromosomes with them and figure out how they're regulated as genes.